Deep beneath the muddy waters of the Mississippi River, a world unseen and often forgotten exists. It's a realm of geological forces, pressures building over millennia, and secrets waiting to be revealed. The river's surface may appear calm and serene, but beneath lies a different story. A story etched in stone and whispered through the earth. Something is stirring. A subtle shift, a low rumble, a sign that the earth is not as still as we might think. Geologists are listening closely, using sophisticated instruments to amplify the faintest sounds emanating from the depths. They are the Earth's doctors, diagnosing its ailments and searching for clues about its hidden processes. Picking up faint whispers and groans from the Earth's crust, potential warnings of impending seismic activity. These aren't just random noises, they are coded messages, geological Morse code that, when deciphered, can tell us about the stresses and strains accumulating far below. Imagine the river flowing over immense fractures in the rock, a network of cracks and fissures hidden beneath the water's surface. These aren't just superficial blemishes, they are deep wounds in the Earth's crust, like cracks in a giant piece of pottery waiting to shatter. Each crack represents a potential fault line, a zone of weakness where the Earth's crust can slip and slide. These cracks, hidden from view, sit under immense pressure, squeezed by the weight of the Earth above and the forces of plate tectonics. It's a slow, relentless process, like a vice tightening over time. Sometimes that pressure builds until snap, the breaking point is reached. The energy is released as an earthquake, sending shockwaves rippling through the ground. The Earth's pent-up frustration unleashed in a sudden, violent burst. The Mississippi region, especially in the central U.S., an area often overlooked when we think about seismic activity, has a history of these sudden snaps, a reminder that even seemingly stable landscapes can be vulnerable. While not as famous as California, with its well-known San Andreas Fault, the quakes here have been enormous, capable of causing widespread devastation. That's why scientists are using advanced technology to peer beneath the surface, employing cutting-edge tools to map the fault lines and monitor the stresses building within the Earth. Checking the Earth's pulse for signs of trouble, looking for subtle anomalies that could indicate an impending earthquake. They're not predicting the exact moment of disaster because earthquake prediction remains an elusive goal. But they're mapping out the risks, identifying the areas most vulnerable to seismic activity. Knowing where the weak spots are, understanding the geological landscape, helps us prepare for what could come, allowing communities to develop effective emergency response plans. The Mississippi is a lifeline for America, a vital artery of commerce and transportation, transport, carrying goods and materials across the nation, water, providing drinking water and irrigation, wildlife, a rich and diverse ecosystem, all at risk if the ground shakes. A major quake here could have huge consequences, disrupting the economy, damaging infrastructure, and endangering lives. These geological alerts are a call to learn, prepare, to educate ourselves about earthquake risks and take steps to mitigate them, and respect the hidden power beneath our feet, acknowledging the forces that shape our planet. It's science in action, a constant effort to understand the Earth's complex processes, helping us live smarter on our dynamic planet, making informed decisions to protect ourselves and our communities. The story of the Mississippi isn't just about water and commerce. It's not just about the bustling river traffic and the economic activity it supports. It's about the restless earth below, the geological forces that have shaped the landscape and continue to influence our lives. By listening to these whispers, by paying attention to the subtle signs of seismic activity, we can better protect what matters most: our communities, our infrastructure, and our way of life. The river's calm surface, a picture of tranquility, hides a world of seismic secrets, a reminder that even in the most peaceful settings, the Earth is always moving, always changing. Deep beneath our feet, the Earth's crust is not a solid, unbroken mass. Instead, it's riddled with fractures, invisible lines etched into the very fabric of our planet. What are these cracks, these hidden pathways within the Earth? In geology, we call them faults. They are more than just simple cracks. They represent a fundamental weakness in the Earth's structure. Imagine a giant slab of rock, miles thick, subjected to immense forces, pressures that build up over millions of years. These forces are relentless, pushing and pulling, twisting and contorting the rock. Sometimes it bends, slowly deforming under the strain, like taffy being stretched. The rock yields, accommodating the pressure in a gradual, almost imperceptible way. But if the force is too great, Exceeding the rock's ability to bend and deform, it breaks. The breaking point is reached and the rock can no longer withstand the stress. That break is a fault, a rupture in the Earth's crust where the rock has fractured and moved. Often a complex zone, not just a single line, but a network of interconnected fractures stretching for hundreds of kilometers, a testament to the immense power of geological forces. Beneath the Mississippi River, a seemingly placid and unchanging waterway, especially in the New Madrid seismic zone, a region that history has shown to be anything but geologically quiet, lies a significant system of ancient faults, a hidden network of fractures that tells a story of the Earth's tumultuous past. These faults are remnants of old geological events, echoes of powerful forces that shaped the landscape millions of years ago. Scars left behind in the Earth, a permanent record of the planet's dynamic and ever-changing nature. Most of the time, faults are locked by friction, the immense pressure holding the broken rock faces together, preventing movement. But stress keeps building, slowly and inexorably, as the Earth's tectonic plates continue to shift and grind against each other. The New Madrid faults are unusual, presenting a unique geological puzzle to scientists. They're intraplate faults, far from tectonic plate edges, located in the heart of a continental plate, a place where such activity is not typically expected. This area covers parts of Missouri, Arkansas, states that are more often associated with agriculture than with seismic activity. Tennessee, Kentucky, states steeped in history and known for their natural beauty, but also underlain by these hidden faults. And Illinois, a state with a diverse landscape and a rich industrial heritage, also shares this geological vulnerability. Scientists believe these faults exist, not as random occurrences, but as the result of a specific geological history, due to ancient rift zones that weakened the crust, creating zones of weakness that persist to this day, millions of years after their formation. When stress overcomes friction, when the built-up pressure exceeds the holding power of the rock slips, suddenly and violently, sending out seismic waves, earthquakes, vibrations that ripple through the earth, carrying the energy of the rupture. Small slips cause tremors, barely perceptible shudders that might go unnoticed by most people. Big ones can shake vast areas, causing widespread damage and disruption, a stark reminder of the power of the earth. The faults beneath the Mississippi, hidden from view but ever present, have proven they can do just that, unleashing devastating earthquakes in the past that reshaped the landscape and altered the course of the river itself. That's why they command so much scientific attention, as researchers work tirelessly to understand these faults and assess the potential risks they pose. Let's travel back to 1811 and 1812, when the central Mississippi Valley was rocked by a series of legendary earthquakes. These weren't minor rumbles. They were some of the largest ever recorded in the continental U.S., east of the Rockies. The ground rolled like ocean waves, huge fissures opened, and the air filled with sulfur fumes and dust. The Mississippi River itself was thrown into chaos, even appearing to flow backwards in places. Giant waves surged, reshaping the land in minutes. Shaking was felt as far as Washington, D.C. and Boston. The seismic energy traveled far, a hallmark of central and eastern U.S. quakes. Even with sparse population, the effects were widespread. The New Madrid earthquakes set a benchmark for what this region can unleash. Their legacy still shapes how we view seismic risk in the heartland. The 1811-1812 New Madrid earthquakes were a series of seismic events that reverberated across the central United States. These weren't just minor tremors. They were powerful, earth-shattering occurrences that left a lasting impact on the landscape and the people who lived there. These massive earthquakes didn't just shake the ground. They fundamentally transformed the landscape, leaving an indelible mark on the region. The very shape of the land was altered in dramatic ways. The Mississippi's path changed in response to the intense seismic activity. The powerful forces at play caused the river to deviate from its established course. This happened as land was thrust up, creating new elevations, or sank, leading to depressions and low-lying areas. The ground responded violently to the earthquake's energy. The shifting landmasses resulted in the creation of new rapids, where the water rushed over newly formed obstacles and entirely new channels for the river to flow through. Perhaps the most famous and enduring result of these cataclysmic events is Reelfoot Lake in Tennessee, a testament to the raw power of nature. This unique lake was formed when the land sank dramatically, and the relentless waters of the Mississippi River and surrounding areas flooded in, creating a new body of water. The surrounding forests were utterly devastated by the earthquakes and their aftereffects. Countless trees were uprooted from the ground, while others were drowned by the rising waters, leading to the formation of new swamps and wetlands in the altered landscape. In a phenomenon known as sand blows, vast quantities of sand erupted from the ground. This occurred as liquefied sand, turned into a slurry by the intense shaking, shot violently to the surface through cracks and fissures in the earth. This process resulted in the fertile fields being buried under layers of sand, rendering them unusable for agriculture. The relentless force of the earthquakes caused riverbanks to collapse into the water, and entire islands vanished beneath the surface. As a result of these changes, navigation on the Mississippi River became incredibly treacherous and unpredictable, posing significant challenges for river travelers. The familiar landmarks that river pilots had relied upon for generations were suddenly gone, erased by the powerful forces of nature. The old, predictable waterway was replaced by a new, unpredictable course, making travel dangerous and uncertain. These dramatic changes serve as a stark reminder of how a major quake can reshape not just cities and human settlements, but the very land itself, leaving a lasting legacy on the environment. Historical accounts and geological records remind us of the sheer scale of disruption that is possible when the Earth unleashes its power. The Mississippi's story is indelibly written in the scars left by these quakes, a testament to the region's seismic past. Nature's power to both create and destroy, to build up and tear down, is on full display here, etched into the very fabric of the landscape. It's a profound lesson in respecting the immense forces that lie hidden beneath our feet, forces that can reshape our world in an instant. More than 2 centuries later, the New Madrid seismic zone is still a concern. The faults remain, and stress continues to build, slowly but surely. A major quake here could affect millions, with seismic waves traveling far and wide. Today's infrastructure, bridges, pipelines, power grids, is far more vulnerable than in 1811. Even a moderate quake could cause massive disruption. Scientists focus on both the hazard and the risk, not just if a quake will happen, but what it could do. Ongoing research and monitoring are essential for public safety. The sleeping giant beneath the Mississippi demands our attention. In 2025, monitoring the New Madrid seismic zone is more advanced than ever. Networks of seismometers detect even the tiniest tremors, sending data to research centers. High-precision GPS stations track subtle shifts in the Earth's surface, revealing where stress is building. Geological field studies and seismic imaging map the hidden faults below. All this data helps scientists refine their understanding of the region's risks. The consensus: the NMSZ remains a significant seismic threat. Research is ongoing, models are improving, and vigilance is our best defense. Science is our early warning system. Many thought the eastern U.S. was geologically quiet until recent events proved otherwise. The 2020 Sparta, North Carolina earthquake, though moderate, produced a rare surface rupture. It showed that even quiet regions can host active faults and damaging quakes. The event caused millions in damage and highlighted the need for preparedness everywhere. Ongoing research into Sparta and similar quakes is reshaping our understanding of eastern U.S. hazards. Scientists are now looking more closely at other regions with similar geology. These discoveries inform building codes and community safety plans. The Earth can still surprise us even in ancient landscapes. How do scientists study hidden faults? It's detective work, using seismology and more. Seismometers record earthquake waves, helping pinpoint epicenters and magnitudes. Paleoseismology uncovers evidence of ancient quakes by examining soil and rock layers. Imaging techniques like seismic reflection create ultrasound maps of underground faults. Computer models simulate stress and predict where future quakes might strike. It's a cycle of data, analysis, and refinement, always seeking a clearer picture. This relentless research helps us understand and prepare for the Earth's restless nature. If a major quake struck the New Madrid zone today, the impact would be devastating. Cities, infrastructure, and millions of lives are at risk, far more than in 1811. The Mississippi's role as a commercial artery means disruption would ripple nationwide. Damage to pipelines, power lines, and transport routes could cripple entire regions. Environmental consequences, landslides, contamination, altered landscapes would be severe. We can't prevent earthquakes, but we can prepare, retrofit buildings, plan responses, and educate the public. Emergency kits and safety drills save lives. Science gives us knowledge, preparedness gives us resilience. By learning from history and listening to experts, we can build safer communities. The restless Earth demands respect and readiness.